Hello everyone. I'm some random cuber, and in this video I'm going to be showing you how to create visual Rubik's cubes like this, or this using your computer and no softwares. Hi, sorry for not uploading it forever, but thank you so much on the support on my last video. We had 100 views, which I didn't expect this early. In that video, I stated a 50 sub Q&A special, but, yeah. I guess I'll just wait till 100. Also, my Discord server link is in the description, go join. Now, onto the video. So, this video will show you how to create virtual cubes, like I said before. I do not know this for sure, but I believe that JPerm, as well as derpycuber sometimes, use this software, but this way of creating virtual cubes is better than just peeling the stickers off like the person who did it over here, or what YouTubers like Pranav Patula do, like that. This is a much better way of doing it, and in order to do it, you need to go to this link, cube.rider.biz /visualcube.php. And this is where we can start learning how to create the virtual cube. So let's get started. This software was created by Conrad Ryder. There's also another virtual cube type of software that also has animations and looks like this. So I still don't know how exactly to do this, but if you want me to learn and show you guys at some future video, I will do that. So comment down below if you want to see that. If you look on this website, you can see that this is a website that allows you to generate custom Rubik's Cube visualizations from your browser address bar. And this can create Rubik's cubes like this. You can change the background color, what the cube is showing. You can do it like in this PLO form, and there you can add arrows. There's some like parts in which they can be invisible, and just customizing all the stickers and stuff like that. So over here you can see a list of parameters, and each parameter is basically like a trait for what the cube will have at the end. So if you can see over here in the URL, there are a bunch of parameters. For example, FMT equals PNG, size equals 600, PZL equals 7, and they're all separated by this AND symbol. The first parameter is passed with a question mark, and so let's look at the parameters and what each parameter is. So starting with this section. So first off, to get from this page to an actual cube, drag this sign over to a new tab like this, and it'll open like that. So now that you should have two tabs, and they both show like the written page on how to create all the cube thingies. So in order to show up a cube, what you want to do is add question mark FMT equals PNG. So right now you could see it's still loading, but it shows currently a cube with the wrong color scheme. We can fix that later. I'm not exactly sure why it does that, but it does. So this basically just changes the format of the file. So right now, if I were to download this, so save image as, which would download it, you could see that it would download it as a PNG. There are a bunch of different formats, such as GIF, JPEG, SVG, TIFF, and ICO. I don't know what some of these are, but PNG and GIF are recommended. PNG is a image format that supports virtual background, and I'll show you how to have virtual background on the cube. You could either pass in this first parameter fmt equals png like this, or instead of doing this, let's go back over here, you could just delete this PHP and change it to whatever extension you want it to be. So PNG like this, it does the exact same thing. So now on to the next parameter. Usually what I do if I create a virtual cube is I would add a new parameter called size equals 600, and this just changes the size of pixels, and now you can see it has the correct color scheme. And this is the default color scheme. It comes with yellow on top and blue in front, and it's the regular color scheme across the whole cube. So now you can see that the size is 600 by 600 pixels. It'll also show you the size over here. And the max it can go to is 1024. So it can't go higher than this. For now, I'm just going to leave it at 600. Another thing you could do is change the puzzle type. So over here it says they have a to-do list in which they want to add puzzles like Square 1, Megaminx, and Pyraminx. As of now, they haven't added that yet, but hopefully they will sometime in the future. So in order to add another parameter, we have the AND sign, which you could do by pressing Shift 7. And now you type PZL, which stands for puzzle, equals 3. So 3, that just means 3 by 3. It can go from a 1 by 1, like this, all the way to a 10 by 10, like this. So some of the features do not work on all of them. For example, these two parameters do not work on cubes 4 by 4 or higher. By the way, you can see the default of each parameter over here. So currently, if you look over here, it'll show the default for all the parameters. So you can see right now the puzzle type is 3. That's the default, which means it's a 3 by 3. Let's look at the view parameter. So in this parameter, you can have it be a regular Rubik's Cube like this. And then if you have a plan in that parameter, it'll show it like this, which is like that view that usually PLLs are done in. And there's also a trans, which means transparent, which will make the whole cube transparent. There are other ways of doing this, but this is one of them. So now I'm going to go back to the regular view by deleting this view parameter. And once it's back like this, we can check out the next parameter, which is stage. So later on, there will be a parameter in which you can change each sticker's color by hand, sticker by sticker, but this stage basically has a bunch of presets right here, and you can just choose them instead of choosing each sticker's color. So right here, let's check out this first one, for example, FL. And this basically shows you the first layer. So now you can see only the first layer is solved and the rest of the cube is unsolved. And there's F2L, so the first 2 layers. And then last layer. Let's say that you had the cross like this. So now you could see there's a cross currently solved on the white side. Let's say you wanted the cross to be on the blue side. In order to do this, you would need to turn the whole cube doing an X rotation so that you could see the cross on that side. Based off of that, we can say cross dash X, and then it shifts the whole cross over here. But instead of doing the whole cube rotating, it just does the cross, it just moves the cross preset to this other color, which is pretty cool. Now you could have, let's say, X2, so that the cross will be on the top, face, and you could do all sorts of stuff like that. So let's say F2B, so first two blocks, like in real, you could change that to -z prime. And you could see over here, also if I press enter, the apostrophe will turn into a %27, and that's fine. It's basically the hex code for an apostrophe. So now you could see if I did z prime, of course with blue as the F face, then the first two blocks are these two. There is an option to change the view from basically looking at this corner like that to maybe just you want to look at one side, or you want to see this at a different angle. So what you would do is this parameter r equals, now you can set which angle you would want this to be in. So let's say I do in the x direction I want 0 degrees, then it'll just show me this face. At first you can see only the F face, and then the default is y45 x -34, which basically means it turned 45 degrees this way and 34 degrees this way. You could also do positive 34 like this, and then it'll show the bottom. And you can also add some Z rotations in there if you want to. And there's a bunch of stuff like that, so you could like change it. I found also y40 x -30 to be a pretty cool rotation angle, but you can just choose it like that or just stay with the default, so like this. So now onto this next parameter, which is alg. This is pretty straightforward. It's just the alg that you want to be executed on this cube. So let's say you want the sexy move, so R prime U prime, make sure it's capitalized like it usually would be in a scramble. And you could see that this, if I turn this cube around a little more, this is exactly what you would get if you were to do the sexy move in a regular solve. So there is this option, and the moves that could be inputted in here are X and Y rotations, like this, or there could also be, of course, R, which is the regular R move. There is also lowercase r, which is the 2 layers. It's basically R wide, like this. If I could only do little lowercase r, it looks like this. There are also M slices. So if I do M, it looks like this. And so yeah, you could do any of these algorithms. And so like there is this alg parameter, there's also this case parameter. So let's say I input the sexy move into here. You could see that for this case, this in a regular cube, you would need a sexy move to solve this, and that's what the case parameter does. It basically shows the case in which it takes these moves to solve it. So that's pretty cool, and you could show different stuff like that. Now, if you remember from before, I said that there's an option to change each sticker individually, and this is possible with the FD or FC parameters. Before I show you this, let me show you this sample cube that I have created. Actually, before getting into that, let me show you what the colors are, what the color inputs could be. So this is used in the FC parameter, the SCH, the BG, and CC parameters. And The colors are shown over here. N for noir or black, D for dark gray, L for light gray, S for silver, W for white, Y for yellow, R for red, O for orange, B for blue, G for green, M for magenta, P for pink, and T for transparent. So you could also choose a hex code, which is basically if you go to htmlcolorcodes.com, you could choose a certain color that you choose. Let's say this color, for example. So then you could copy and paste these letters and numbers over, like for example, in this, you could input this as the value for SCH or BG or CC, but not for FC. So I'll show you what these do later, but those are the colors that you need to know. And so now in order to show you what FD and FC do, so these two change the color of each sticker, as I said before, and in here they're called facelets. So here I've created the sample cube to show you the order in which the faces are mentioned. So how the inputs for FD and FC work. So for FD, you can either put the U, R, F, D, L, or B as in the faces, and these are each color of each face. And FC is almost the same thing. It allows you to select from more colors. So instead of choosing it by each face, you can choose by each color. For example, in 3x3, you would see these letters. So these 9 letters show the colors of these 9 stickers. It goes like this. So you could see there are 9 Ys at the beginning. So this one, and then this one, then this one. So it goes like this. And so I've created this cube to show you that first it selects all of the colors from this U face, and then from the R face, and from the F face, and then 4 is the D face. Side 5 is over here, it's the L face, and you can see this 6th face on the back. And these just show the order in which each face is defined. So you could see over here I've written this long line of a bunch of Y's and N's. So the Y is for yellow and N is for black. The link for this cube will be in the description too if you want it. Or you could just remember that the order is U, R, F, D, L, and B. So how we change each color of each face is, for example, in FD, you could already see here U, R, F, D, L, and B. So in here we can change. So let's add the FD parameter. We want these first 9 to be in a certain color. So if we have the FD, there are these 3 special colors. So N for a dark gray color, which is a blank face. So for example, in here you saw in the stage parameter that these first 2 layers were solved. So this last layer was colored with the N definition. So N is this color. It's, I think, dark gray. O is an oriented face, which is colored silver. And this is, for example, in ZZ where you orient pieces, they are colored silver sometimes. And then T is for the transparent face, and it will not appear on the cube. What you could do in here is set the FD parameter. Let's say because it sets the first face, like the U face first, then let's say we want it to be the blank face color, so N, and then we type that 9 times for each sticker. So now you can see that was 9 times. And then onto this next face, let's say we want the first three over here to be blank, and then these two to be the same color as our face. So the first three are making sure that there's no space between each face, and then we do R and R, so that it'll color the first three with the blank color, and these last six with the color of our face. And also the same over here. You could continue to these next layers, to these next faces, so D and then L and then B, but you could also leave it over here, and then the rest of the faces will be colored with the default color. So if I press enter right now, you could see that this first layer over here, it's colored gray, and these next two are colored with the R faces color and the F faces color. You could also change all these F's to, for example, U, so U, and then it'll have the color of the U face, so yellow, and it looks like this. And you could change it to whatever color from the color scheme that you want. Let's say you want that all to be oriented or something. You could do it like that. And there's all types of ways that you could go on from here. But I'm just pointing out that this is just another way to get to the F2L stage. So you can see in here I did stage equals F2L, and in here I changed the face definition, and they're exactly the same picture. So the stage parameter is basically just a preset of each FD or FC. So now onto the FC. It's the exact same thing, it follows the exact same rules, but FC uses colors. So let's say you want this one to be the dark gray color, which is the same color as the N for FC. So we could do D, 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 D. And then for this side, 3 Ds, and then 6 reds, so R, 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 R. And then onto this side, 3 dark grays, and 6 blues, and blues, B, B, B. And then it will look like this, which is the exact same thing. You could also change it to like whatever other color you want from here. So like let's say you wanted it purple or magenta. You could make it be magenta, and all other stuff like that. So the FD parameter, or the facelet definition, it follows of course the U colors and the R colors in FDLB. And so it follows like that, and you could choose between these colors. Over here it shows all the letters that are possible to be in the FD parameter, but this has to follow another color because U, it knows it's the U faces color. It's set from the SCH, or the scheme, or the color scheme of the cube, which is set over here. So you could add, for example, SCH, and now let's change it. So the default scheme is yellow, red, blue, white, orange, green, because that's just what it looks like right here. And that's just the default thing, so what I did right now wouldn't change anything. But let's say I change it to just random colors. So let's say DSMPGR, for example. It just messes up with the colors. So the first one was D for dark gray, then silver, then M for magenta, and you could see over here this is the L face, so G for green and R for red. And then if we do an X move from here, you can see that the bottom has the pink color. So you could mess with the color scheme like that, and then if you change the FD, it will use the U and R and F colors of each face according to the color scheme. We can change the background color of the image or the cube color. So right now we could change the stickers, each sticker alone. So now what we could do is also change the color of the cube itself. You can see right now it's black, we could also change the color of the background. So in order to change the cube color, it's CC for cube color. You can input the same names as each one of these, and you could also input the actual names of each color. So let's say I want the color to be purple. It changes the cube color to purple. Or you could also input the the corresponding letter for that color. So M would also do that. And you could do each of the colors or the hex code. So let's say I wanted this color. I could copy this with Control C. So now let's go to the CC and paste in this color, but without the hashtag. And it changes to the correct color that we chose. So that's pretty cool. And you could also change the background color the same way. So right now, because I deleted the CC parameter and change it to BG, which is background, it'll make the cube color be black, but the background color to be that color, teal. You could also make it T or transparent. And this is mainly useful for, let's say, you are making a video. You could then take this cube and add it over there without it having a background, unless you want a background. Next are these two, CO and FO. The CO and FO change the opacity, which is how transparent the thing is. CO changes the cube's opacity, which is how transparent the cube is, and FO changes the facelet opacity, or the sticker's opacity, which changes how transparent the stickers are. And this is from 0 to 100, so it's by percentages. So let's say it changes CO to be 50. That means that now the cube itself is 50% transparent. And you could see over here from behind all these other colors. And you could see that this bottom face is kind of hard to see right now. Let's just make the CO 0. Oh, sorry, not a dash, it's 0. You could see, you could only see the stickers. So that's pretty cool. You can change the opacity of the cube itself as well as the stickers. So let's say I wanted the opacity of the cube to be 30. But the face opacity to be 40. I could do that. It looks like this, so that they're both the stickers and the cube itself are transparent partially, like that. So then there's this dist. So this is weird. Apparently, I don't know how to describe it, but it says it controls the distance of the cube from the perspective of the viewer. Doesn't mean the cube's smaller or bigger. It basically, well, let me just show you. So 100 would look like this. So you can see this looks like a regular cube. This looks a little weirder. If you enter 1 as the value, looks like this. So not exactly sure how to describe it. This is 3. So the default is 5. I usually don't mess with this. So I'm just gonna keep it at that. Finally, we can create an arrow over here instead of making an arrow from your editing software. So it looks like this. So I'm going to move to the plan view. So view equals plan. So in order to create these arrows, what you need to do is add an arrow, or ARW parameter. And now what you do is you choose certain points or certain stickers in which the arrow will connect. So first of all, you specify which side it is, because you can also, by the way, move the arrow from different sides, or make it on the right side or the front side. So let's say I want it on the top side. I can make it, so I say U, make sure it's uppercase. And now I need to specify which specific sticker. The stickering looks like it is on screen. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8. So let's say I want it from this corner to this corner. So you could see, because this is sticker 2, I could say U2. And then let's say I want the arrow to be from sticker 2 to sticker 8, right here, this corner to this corner. Could say, U2, U8, like this. And this will create an arrow from this corner to this corner. And it looks like this. You can see right now the arrow is gray, and you can change the color of the arrow using the parameter AC, which means arrow color. This inputs the same colors that were mentioned before, same as the BG or CC parameters. So let's say I want it to be that light blue color thing that we chose earlier. So make sure to remove the hashtag, and now you'll see the arrow is with that color going from U2 to U8. And let's say I want the arrow to go both ways. There's no way to do that with one arrow. I need to create another arrow, so comma, and let's say, so because this goes from here to here, I want to make it go the other way so that the arrow will be in two directions. So we now want from U8 to U2. So let's type that in. Now you can see the arrow goes both ways. So let's say in here, you could see I've created the obviously impossible case, but I've changed it using the FD and changed each letter like that. And this is why the arrows would be useful. Now let's say for some reason you want the arrows to be curved. So let's move back to only one arrow right here. So let's say I want the arrow to go from U2, curve over at U3, and go over to U8. So like this, I could, as I have the U2, U8, I don't add U3 in the middle, I add U3 at the end, like this. Now you can see the arrow curves from U2 over to U3 and then to U8. So for each arrow there could be additional parameters. The arrows can be scaled in a way so that the arrow itself, the two ends, will fall short of the center of the sticker using this S parameter. So in the same line that in these letters that declared the arrow, you do -S for scale, and the default is 10. So it looks like this. But you can see if, for example, I do 5, these endpoints fall short of the center. Like, let's say I want it to be 8. They aren't exactly on the center, but they are closing in together. And not sure if there's a 0. Yeah, okay, there is. So this is where basically the two endpoints got together in this center point, and I guess because they overlap, it only shows this one arrow. So I guess you could use that for whatever. But if I keep it at 10, there's also this other parameter, which is I, so -I, and you could also, in here, this is the same thing, but it basically changes how far the curved point is reached. So the default is 10 again, but let's say let's say I input 5 here, could see that it came closer toward these. So if I do 0, I'm guessing it would be just a straight arrow. So now the last parameter that you could change for each specific arrow is the actual color. So this AC changes the default color for each arrow, but you could actually override that by calling the color over here. So let's say I want it red, make it R, and then it's red. Or you could also say orange, for example, and then it will change the color orange. So I think that's pretty much it. Oh wait, if I'm correct, I think these two can go up to 20. So if I change this to 20, you can see it extends to the side like this. And if I change this to 20, it'll also extend out like that. Let's say, for example, I want to show a T-perm in this plan view. Let's start from scratch by having visualcube.png and the size 600. So right now you have the regular first virtual cube that we had before. Let's change it to the plan view. So view equals plan. Now you could see this side. So now, in order to create the T-perm, we could add an alg parameter and then type in the T-perm. And okay, here we have it. So I wrote in the T-perm correctly. You could see all the apostrophes turn to %27 signs. So now, let's say we want to create the arrows. We can add this arrow. So like before, if you remember, we made an arrow from U2 to U8 and back. So let's type that in. So U2, U8, which would make an arrow from this sticker to this one. And now we want to make an arrow back. So U8, U2, making sure the arrows are separated by comma. And now we want to make an arrow there and back from U3 to U5. So U3, U5, and then U5, U3. And now we can, let's say we also want to make the arrow color be black. And now we have the arrows. You can see that this arrow from U2 to U8 is overlapping this arrow. We can't see this arrowhead. So what we can do is extend this arrow out. So if we remember, we can do that with the scale. So this goes from U3 to U5. So this arrow over here, let's do -S. And then let's make it at 11, for example. And now you can see the arrow is extended, but it's sadly extended from both sides. So you can also see this area. But let's just make it 12. Like that. And now you could actually see the arrow, but you could also see this. So what we could do is on the other way, so U5 to U3, we can also make the scale be 12. And then this is our finished T-perm. One last thing before we finish the video. If you want to copy and paste this into an editing software, so if you have a separate software that isn't like a website, you could right click on this image and click Save Image As. Then you can change the name of it. So in here I'm going to do test. And then you'll be able to access the cube over there and drag and drop it onto your software. So that's basically it for this video. If you want to challenge yourself to learn more about this, you can press on each of these cubes, which will bring you to this website, and you could see what each parameter does. So you could click on any of these to further test yourself. And other than that, subscribe, like, and comment below some Q&A questions or any other comments. So that's it, and see you next time.